Well, how are you doing? Okay, this is called or titled, I should say, calling out Wolfie 6020, and it's about how airplanes fly. Okay, please share this with Wolfie as much as possible and question him on this specific topic, um, because it's extremely important. Okay, Wolfie 6020 is a claimed commercial pilot who is a former military pilot who works for a private company. Wolfie turned up on the Flat Earth Globe Earth scene on YouTube in 2016, if I remember correctly. Wolfie has since then, which is 5 years now, claimed a sphere Earth. Wolfie has, as aforementioned, is a commercial pilot who claims to fly about 10,000 miles per week, if I recall correctly. So it is time for him to put up or shut up. Explanation time. Aircraft fly with their noses between 1 and 4 degrees above horizontal on average. The reason they fly this way is due to how aircraft are designed to fly, by using air pressure differential above and below the wings. Aircraft are pushed ahead through the atmosphere by thrust, and the wings of the aircraft are designed in such a way to create and take advantage of a pressure differential, where a faster moving air glides over the top of the wing, causing a lower pressure system, and slower moving air glides underneath the wing, causing a higher pressure system. Due to entropy, this causes lift, as the higher pressure under the wings strive for equilibrium with the lower pressure above the wings. So, the more thrust that is imparted by the pilot of the aircraft, the faster the air flows over the top of the wings, and the faster the air, the lower the pressure. And as we all know, an increase in pressure differential will mean an increase in entropy. So, more thrust, the greater the entropy. The greater the entropy, the more lift. The more lift, the more tilt the nose of the aircraft will have upwards. So, just before I move on there. Okay, here is an aircraft wing. Fast moving air over the top, slow moving air underneath. Okay, so you have high pressure underneath and low pressure at top. So high will go to low, causing lift of the airplane. So here is from NASA. So thrust is pushing, pulling, pushing whichever the plane forward. You have drag, which is the air resistance, causing a pull back the way because it has to flow through air. You have weight of the airplane, which will cause it to want to go down. Then you have lift caused by thrust, which will allow it to stay up. Okay, so more lift than weight, the plane will rise. More weight than lift, the plane will fall. The more drag than thrust, the plane will slow. More thrust than drag, the plane will accelerate. Okay, so thrust, the more thrust, right, will cause more lift. So the more thrust, the more lift, the more lift, the more the nose of the airplane will tilt upwards. Okay, so and the more thrust, the more lift that is created, then the more the weight of the plane is overcome, and the more thrust creates the lift and also counteracts the drag, and the lift also counteracts the drag. So that's the basics of this effect. Okay, but a byproduct is the nose tilts up the way. So the more thrust, the more the nose will tilt up the way. Okay, because it causes more lift, and the lift causes the pressure differential, which causes the plane to tilt up the way. So the plane's nose is tilted up the way. So here we have the purple line if it's extended, let's just say globe out. Okay, I have written in down here. Here you have the plane going forward, right? So the plane is trying to go in a straight line like this yellow line here, right? But on this model here, the globe out model, it has to be doing this, right? Going down this way. But it's trying to go forward, right? Because that's how it flies. But actually what happens is as it flies, the nose comes up the way. If you can see this yellow arrow here. So what's actually happening is it's flying forward, but with its nose tilted up the way. So it's flying forward at a slight angle, okay? But it's still flying in a straight line, horizontal line forward. But it's flying with its nose above horizontal, because This would be horizontal, but this would be where its nose is, tilted above horizontal. So engine power increases lift, and lift causes the airplane's nose to tilt upwards from horizontal. Here, these lines here, making flight over a consistently curved surface a physics impossibility. So just going to go back there now. So from this, we can conclude that when an aircraft is flying at around 550 miles per hour, which is around the average speed for a commercial Boeing 777, etc., that the nose of the aircraft will invariably be above horizontal by a couple of degrees, as it has no choice under those conditions. You see, aircraft can't not fly with their noses a few degrees above horizontal, as that is how they are designed to fly at cruising altitude for extended periods of time and distance. And every pilot must learn this, as it's a crucial part of information to know for every pilot. So every pilot has to know that the plane that they fly, that it has to fly with its nose above horizontal, because that is how lift works. Now, I've known this for years, and I've known that Wolfie has known this for years. I don't know when I learned this. It was years ago. I don't know when it was, but it was years back. And Wolfie has known this for a long time. So if the plane has to, the only way a plane can fly is by using lift. Okay, the thrust creates the lift. The lift causes the nose to tilt up the way. So that's the only way a plane can fly, with the nose tilted above horizontal. So just go back for a second. But on the globe model, which is Wolfie's model, the nose would have to at some point for a long period of time be below horizontal, because it's not just drop, it's curvature. Because if you flew from London to Perth on the globe model, then you're going to have to, or the other way around, you're going to have to end up 3/4 way upside down. That's the way it is. There is no way around it. So even throwing something like there's a blanket answer from people who are uninformed and uneducated on the subject of gravity will just shout gravity, right? But it doesn't matter what your belief in of what gravity is, or what it is actually claimed to be by modern day pseudoscience. All the gravity belief of whatever you want it to be in the world won't change the physics of the situation. The nose has to tilt above horizontal, so it cannot be flying around something that is falling away from it at magnitudes underneath. It can't be doing that, because as I said, it's not just drop, because a plane can drop in altitude, but it still won't be changing its position. Its nose will still, even if it slows down, its nose will still be above horizontal by a degree or so. And the more thrust the pilot gives the plane, the more lift, so the more the nose will tilt up. So that's why when a lot of planes, when they're flying at top speed, at cruising altitude, their nose will be tilted up the way. Now, I know if they're flying through thin air and stuff like that, people might make that argument, but I have not heard how that would change anything. But either way, the nose and the way the airplane is designed, if you look at the nose of the front of airplanes, especially if you look at the big ones, that really shows it, how the air is designed so the air is pushed underneath the plane. That's the idea. It's pushed down underneath. And that's what happens with the differential of pressure on the wing, at the wings. So how can an airplane be ever doing this down over that shape of a thing, when it's naturally flying, going in a straight line, but with its nose pointed up the way? It's never, ever, ever flying with its nose below horizontal. And if it is, everyone must be strapped into their seats. You're never allowed to walk around when the plane is flying and it's flying with its nose below horizontal. You have to be sat into your seat when a pilot decides to do that. It doesn't happen all the time, but I've been on planes and it did happen, where the pilot was dipped the nose to come into land, and then obviously they landed with the nose up, but to drop in altitude fast, they dipped the nose. You know, I'm not saying it happens all the time, but it does happen. So the point is, they fly for thousands of miles with the nose above horizontal. So it's an impossibility that they can be flying over a curved surface that's dropping away from it, from below them at magnitudes, the further forward they go. So just going to come back. So we agree that it's a crucial piece of information that every pilot has to know. Now, Wolfie is a pilot. So now, Wolfie 6020 has spent 5 years on the opposing side of this argument, the flat earth. And all that time he has been flying commercially as a full-time pilot, I suspect, and given his career and military aircraft history, it would be safe to say, is more than fully aware of this fact. So it wouldn't be a guess or it wouldn't be a stretch of the imagination that Wolfie is more than aware of this, as it's one of the first things he would have had to learn as a pilot. You would have to learn about the four basic things, which would be drag, thrust, weight, and lift. You have to learn them. They're the basics of how an airplane flies. So he definitely knows about this, and he definitely knows about it since at least 2016. Regardless of how long he knew about it before, he has to have known it since at least then, because he has been claimed to be a commercial pilot since then. So if Wolfie 6020 would be kind enough to actually provide some tangible evidence as to how an airplane can fly over a consistently downward curving rotating surface, while an aircraft's wings are taking advantage of entropy by creating a pressure differential, a differential which causes the effect of lift, but also causes the effect of the aircraft's nose to be tilted upwards. And this tilting upwards effect is in accordance with the amount of thrust that is imparted by the aircraft's pilot. So how would successful flight be possible on any other layout other than a flat plane Earth when the effect of wing lift is taken into account? So I would like Wolfie to address this point. How can he fly a plane that is designed to fly in such a way that the nose tilts up above horizontal? It cannot fly any other way. Not for any length of time. Well, it can, but it's going to career into the ground. Because if any pilot flies for any length of time with the nose below horizontal, the nose of the plane below horizontal, it's going to go straight into the ground. That's what's going to happen in a short space of time. So to fly the plane has to fly because of lift, right? Without lift, the plane won't be going anywhere. And because of lift, the nose is tilted above horizontal. So Wolfie, please address this point, as you've spent 5 years avoiding it. And he might try and say he hasn't, but he has. I've asked him, and he wasn't able to deny what I said when I asked him about the nose of the airplane being always above horizontal. He wasn't able to deny it. But how do you explain it then within it? How does this pilot, who is an ex-military pilot and now a commercial pilot for a private company, how does he explain how the plane flies that way, yet still flies over a consistently curving surface? It's a complete impossibility. But he has to either come up with a valid explanation that can be researched and can be proven to be correct and to work within his model, or he has to concede that he can't. What will not be accepted What I will not accept from Wolfie 6020 is any red herring argument put forward by him as a response to this inquiry, i.e., flight chart creation, EQ mount telescopes, eclipses, the equinox, etc., as these are all separate arguments and are not in line with the inquiry of this video. On top of this, I will also not accept ad hominem attacks, blanket answers, i.e. gravity, etc., or claims that my assertions are in some way wrong or incorrect without the addressing of my references, i.e. NASA, etc. What will be accepted, I will accept a total concession that the phenomena of lift for an airplane is not in line with a sphere-Earth belief and is a complete physics impossibility on an oblate spheroid Earth. I will accept that you, Wolfie 6020, has known this information concerning the lift effect of an airplane since at least 2016 and did not care to address it publicly as it contradicted your belief in a globe Earth model. I will accept that your profession, Wolfie, does involve mechanisms that would be an impossibility on a sphere Earth. So Wolfie 6020, the time has come for you to put up or shut up, as your profession disagrees with your world beliefs, so you must now either prove that the effect of lift, which includes upward aircraft nose tilt, can work on your sphere Earth model, or concede that it does not, as you, Wolfie 6020, have spent 5 years at this point attacking flat Earth and those who propose it, without ever addressing the basics of how your profession Your profession agree with a flat Earth and not a globe Earth. So Wolfie, the ball is now in your court. You have to address this. I'm not interested in any ad hominems. I'm not interested in red herring arguments. I'm not interested in hand wave dismissals. I'm interested only in the addressing of this point. You've got to show how it's possible for an airplane to fly with its nose above horizontal constantly for thousands of miles, flying at 500 to 600 miles per hour. Right, that's the commercial airplanes, and still be accounting for the drop and curvature of your globe Earth model as per its mathematics. Now, the final nail in the coffin is this. So takeoff. Takeoff is an impossibility without wing lift, as wing lift causes the effect of tilting the airplane's nose upwards. So to take off, the airplane needs to build up thrust, which causes the pressure differential between the bottom and top of the wings. So entropy takes place, and the higher pressure underneath the wings wants to go to the lower pressure above the wings. It's a natural thing, entropy, right? So that is what causes takeoff, right? And once the airplane gets up at cruising altitude, they can then relax maybe on the amount of thrust they need, but they still must keep enough thrust to overcome the drag and keep enough lift to overcome the weight, right? So here is what NASA have to say about it. So what makes a plane go up? Okay, this is from NASA. Now, Wolfie has to address this if he's got a problem with what I have to say. What makes a plane go up? Question mark. Air. A plane flies through the air by continually pushing and pulling the surrounding air downward. In response to the force of moving the air down, the air pushes the airplane upward. Newton's third law of motion states that for every action there is an equal and opposite reaction. I won't go into Newton's laws of motion. An airplane wing is shaped so that the air is deflected downward as the wing passes. Because air is a fluid, a gas, both the top and the bottom surface of the wing deflect the air. This is very different than dealing with solid pellets for which only the bottom surface would deflect. The faster an airplane travels, the more lift is generated. Inclining the wing to the wind also produces more deflection and more lift. So an inclining of the wing increases the lift and the deflection. The wings of an airplane have adjustable flaps that can be extended or retracted. When extended, the flaps increase the deflection of the air and provide greater lift for takeoff and landing. As it flies, a plane is a plane is in the center of four forces: lift, upward force, and thrust, forward push, provided by a propeller. Get a plane into the air: gravity, which is referencing weight, let's just say, and drag, air resistance, which is friction caused by air rubbing against the plane. Try to pull the plane down and slow its speed. A plane must be built so that lift and thrust are stronger than the pull of gravity, which is basically weight, and that's what they really mean, and drag by just the right amount. Lift from the wings is used to overcome the force of gravity, weight. Shape is important in overcoming drag. For example, the nose of the plane is rounded so it can push through the air more easily. The front edge of each wing is rounded too. An airplane built like a railroad boxcar just wouldn't fly very well. So they're basically saying that the whole airplane is designed to take advantage of lift. That's the whole point of it, is taking advantage of the air pressure differential. And so consequently, and if you incline the wings, you increase the lift. So the lift, it's like a two-way thing. If you incline the wings, you increase the lift, but also the lift causes the airplane to incline anyway, because it causes the nose to tilt up. So either way, it's like there is no other way around it. For takeoff, for landing, and for flight, airplanes have to always fly with their nose above horizontal. That's just the way it is. So basics of this, right? How does an airplane take off? Just keep it basic. A plane's engines are designed to move it forward at high speed. That makes airflow rapidly over the wings, which throw the air down toward the ground, generating an upward force called lift that overcomes the plane's weight and holds it in the sky. There's the basics of what actually happens. So this cannot be doing that if it's forced to have the nose doing this, and to go in that direction. So for the airplane to go straight and horizontal, right, it has to fly, and which in such a way it has to take advantage of lift and fly in such a way that forces the nose of the plane above horizontal. So its nose will be up here. For it to go forward, its nose has to be basically tilted up the way. So how can it be going down there? It can't. It can never be doing that. This doesn't happen. But Wolfie is a pilot. He's been a military pilot, and he's also a commercial pilot. Now, I don't know if he can fly both helicopter and airplane or whatever, but I'm only asking him about this and this effect. So please, Wolfie, would you please address this and address this particular point and not red herring me or ad hom me or hand wave it away? You've spent 5 years attacking us, so I want you now to either put up or shut up. It's either address it and concede or go away. One or the other. Thank you.